So we've got a student holding a golf ball and a table tennis ball out of an upper window of a tall building. The balls are released at the same time. Both balls have the same size. The golf ball has a greater mass than the tennis ball. One of the balls reaches a greater terminal velocity. State and explain the acceleration of the golf ball immediately after its release. Okay, so the only force acting at this time is the weight. Therefore, the acceleration will equal g. An important point to make a note about here is if you've put g as 9.81, you must include the unit. Without the unit, you're not going to score the second mark. So, let's moving on then. By referring to the forces acting on the golf ball, explain what is meant by terminal velocity. You get terminal velocity where the drag on the golf ball will equal the weight of the golf ball. Part 3, explain which of the two balls reaches the greater terminal velocity. Back up in the question up here, it's telling us that the golf ball has got the greater mass, so the golf ball has the greater terminal velocity. And the reason for that is because we've got the weight of the object, and at terminal velocity the drag is equal to the weight. So if it's a larger weighted object, we need a larger drag, so a larger drag force is required. So it has to be travelling faster. To achieve that drag force. Than the table tennis ball. Okay, let's move on to part B, where here we've got a graph of drag D against speed. So drag against speed for a lorry. Make a note that the drag is in kilonewtons. We've got the speed in meters per second. The lorry has a mass of 8,000 kilograms. Its engine provides a constant force of 3,200 newtons. Okay, we've got to calculate the instantaneous acceleration of the lorry when travelling on level road at 25 meters per second. So if we just do a quick little free body diagram, we've got 8,000 kilograms. We've got the driving force of 3,200 newtons, and we've got a drag force pushing it back, and we need to go and have a look at the graph to work out what that drag force will be at 25 meters per second. So 25 meters per second is coming up here, and coming along I'd read that as 2 kilonewtons. So 2,000 newtons there. And we know that F is equal to ma, and most importantly the F in F equals ma is the resultant force, so that's going to equal 3,200 minus 2,000. And if we rearrange this, we're after the acceleration, so A equals F over m. So if I divide that through by my 8,000, that will give me an answer of 0.15 meters per second squared. And part 2, we've got to explain why this lorry cannot travel at a speed of 40 meters per second on a level road. So again, if we come back to our our graph, if we're travelling at 40 meters per second, then I'm coming off here, and that's looking like around about 5,000 newtons of drag force, which of course is greater than 3,200 newtons of the engine. So, just to explain that, the drag force is greater than the driving force.